Okay, so congratulations, you guys survived absolute value. Now we're going to talk about piecewise functions, and these are really cool graphs that you will see again in pre-calc. Okay, so here your I can statement is I can evaluate graph and write piecewise functions. A piecewise function is a function defined by at least two different equations. So it's going to have that funky little bracket. That's really fun to make. It kind of looks like a face. But that's going to help identify our piecewise functions, okay? And what's key here is each equation applies to a different part of the function's domain. So the reason that it's a piecewise function is because it's taking pieces of other functions and giving them specific x values. You'll really see what I mean when we graph it. An example of a piecewise function we just covered. Absolute value is most definitely a piecewise function because it can be either positive or negative. Think back to when you solved those in Algebra 1, and you did. Okay, you rewrote it as two different equations. And there's another example. This is what you guys will be dealing with today. Okay, so what we're going to do is we're going to evaluate that function above when x is 1 and then when x is 5. So what's key is I have to pay attention to that domain. A tells me x is 1. So I'm going to look at my function and I'm going to say, okay, well, if x is less than or equal to 1, I can use this function. Okay, well, I have 1. So does that count? Let's see. Oh yeah, 1 is less than or equal to 1. It's equal to 1. So that tells me I need to use this top function here. 2 times 1 minus 1. 2 times 1 is 2 minus 1 gives me 1. Now let's do the bottom one, or the next one. X equals 5. Okay, so x is 5. So this one says it has to be less than or equal to 1. Well, I have 5. Doesn't work. Here, x is greater than 1. 5 is bigger than 1, so I'm in business. I can use the second equation there. 5 times 3 is 15, plus 1 is 16. Okay, so now we're going to graph a piecewise function. Now, there's two ways you can do this. You can graph using slope and y-intercept and then just erase and adjust for the domain later. Or what you can do is use each one of these specific domains to give you the endpoints of your graph. So what we're going to do is we're going to tackle this first one. It says my function is negative 3/2 x minus 1 only if x is less than negative 2. So we're going to take negative 2 and we're going to put it into our function to give us an endpoint. And then we'll adjust with what type of dot we need later. So I'm going to take negative 3/2 times negative 2 subtract 1. Okay, remember, fraction times a whole number, multiply straight across. So I actually end up with 6 over 2 minus 1, which gives me 3 minus 1, which is 2. So I plugged in a negative 2. I ended up with 2. So the first point, the end point of this graph is going to be negative 2, 2. However, I have to be very careful here. This domain is very specific. It tells me x has to be less than negative 2. So x cannot be negative 2. So I'm going to go to negative 2, 2. And I'm going to put an open dot because I cannot use that value or that point as a solution for this equation. Okay, then what I'm going to do is pick a different value. It says my domain x has to be less than negative 2. So I'm going to look on my graph and I'm going to say, well, here's my first dot. X is less than negative 2 this way. So I'm going to pick, I don't know, let's pick negative 4. Let's pick negative 4 and put that in there. Okay, that's a lower x value. So we're going to go negative 3 times negative 4 minus 1. Negative 3 times negative 4 is 12. 12 divided by 2 is 6, minus 1, which is 5. So this tells me the next point on that graph is negative 4, 5. So I'm going to go to negative 4, 5, and I'm going to put a dot. And it's okay to put a closed dot there because I use x is negative 4, and negative 4 is most definitely less than negative 2. So now I'm going to connect my open dot with my closed dot and use an arrow, because it's okay for me to choose any values as long as they're less than negative 2. Okay, it's a lot, I know, don't worry. We'll do it with practice. So now let's do the second one. The second one tells me x plus 1 if x is between those two values. I'm going to do the same thing. I'm going to use those as my endpoints. And that way I don't have to worry about what's in the middle. So this one, it says x is greater than or equal to negative 2. So it's okay to have negative 2 here. So we're going to take negative 2 and plug it in for x, for that function. When I plug that in, I get negative 1. So my very first point is going to be negative 2, negative 1. And I'm going to put a closed dot because it's okay to have it there. Now we're going to plug in the other endpoint. We're going to plug in 1. 1 plus 1 is 2. So my next point is 1, 2. And again, another closed dot because it's an equal to symbol. Now the last thing to do is to look for what this domain is saying. X is bigger than or equal to negative 2. Okay, so if here is x is negative 2, it's this way, and less than or equal to 1. So this way. So I'm going to connect those two endpoints, because what my domain is saying is x is between those two values. Here, all of the solutions between those two values work for that equation. Almost done. Whew. Last one. This one says my function is 3 if x is bigger than 1. So this one's a lot easier. All I'm going to do is I'm going to go for where y is 3. Because this is saying my function y, remember f of x is the same as y, f of x is 3 as long as x is bigger than 1. So I'm going to go to 3. Okay, and it says x has to be bigger than 1. So that tells me 1 cannot be a solution, but that's part of my domain. So I'm still going to use that 1. I'm just going to put an open dot at 1. Okay, so I can have, remember, when you graph these functions like y equals 3, all you're doing is you're going to the y-axis and you're putting a horizontal line. That's what you're doing. And this is the same thing, you're just being very specific at your x values. So this one says y is 3, but x has to be bigger than 1. So there we put our open dot to show it cannot be 1. And which way are the x is bigger than 1? This way. We are finally done. So remember, plug in the domains as your endpoints, and it'll really help you figure out that graph.